Voyager 1 sends a signal from the edge of forever. Humanity's oldest spacecraft lives again. There's perhaps no better demonstration of the folly of human conceits than this distant image of our tiny world. Carl Sagan, reflecting on the pale blue dot photo taken by Voyager 1. Satellite, an echo from the abyss. For months, a deep and unsettling silence filled NASA's Deep Space Network, an eerie quiet from 24 billion kilometers away. Voyager 1, the most distant man-made object ever launched, had gone dark. In 2022, and again in late 2024, engineers feared the worst, that the aging probe, launched in 1977, had finally succumbed to the wear of time and radiation after nearly half a century in space. But then a signal, a whisper from the interstellar void. Voyager 1 was alive. After months of silence and garbled data, the longest operating spacecraft in history had resumed transmission. It wasn't just a technical miracle. It was a reminder of what humanity can achieve when curiosity outweighs fear, when exploration becomes a calling, and when perseverance endures beyond the bounds of time and space. Rocket Voyager's legacy, a journey like no other. Launched in 1977, Voyager 1 and 2 were never supposed to last this long. Originally designed for a 4-year mission to study the outer planets, they have become immortal icons of human discovery, now voyaging through interstellar space, a realm that, until recently, existed only in theory and science fiction. They have traveled farther than any object ever built by humans. Over 24 billion kilometers, Voyager 1. Over 20 billion kilometers, Voyager 2. Their mission has long since transcended its original purpose. They are not just probes, they are interstellar messengers, scientific pioneers, and time capsules of Earth's hopes and knowledge. On board each probe is the golden record, a phonograph carrying the sounds of Earth, greetings in 55 languages, music from Bach to Chuck Berry, and a message to the makers of music, all worlds, all times. Shooting star first light, the outer planets unveiled. When Voyager 1 and 2 began their journeys through the outer solar system in the late 1970s and 1980s, they revealed a world that no one had seen before. Jupiter. Voyager 1 provided the first close-up views of the gas giant's roiling clouds, lightning storms, and the iconic Great Red Spot, a cyclone wider than Earth that has raged for centuries. Saturn. Voyager 1 and 2 showed us the majestic ring system in dazzling detail for the first time, a silent cathedral of frozen beauty orbiting a golden planet. Voyager 2 then broke off, using Saturn's gravity to slingshot toward even more distant destinations, Uranus and Neptune, becoming the only spacecraft in history to visit these planets. At Uranus, Voyager 2 discovered a bizarrely tilted magnetic field and a strangely serene atmosphere, along with 10 new moons and 2 faint rings. At Neptune, it found chaos, supersonic winds, a massive dark storm, and an active moon, Triton, with cryovolcanoes that spewed icy material into space. These flybys reshaped humanity's understanding of the solar system. What were once faint specks in telescopes became complex, active worlds. Milky Way beyond the planets, into the interstellar unknown. After completing their primary missions, both Voyagers set their course for interstellar space. In August 2012, Voyager 1 crossed the heliopause, the boundary where the solar wind from our sun meets the vast cold interstellar medium. It became the first spacecraft ever to leave the solar system. But what Voyager 1 found there was not what scientists expected. Instead of a near vacuum, the probe encountered surprisingly high particle densities, around 0.1 particles per cubic centimeter, twice what scientists had predicted. More puzzling were the fluctuations, waves of denser and thinner regions, suggesting a microstructure in what was once assumed to be empty space. Even more astonishing, Voyager 1 detected plasma waves, regular oscillations traveling through the interstellar medium. These measurements revealed charged particle densities, hinting at ancient supernovae, cosmic filaments, and possibly even undiscovered magnetic structures woven through the galaxy. Satellite antenna Voyagers, technical challenges, dancing on the edge of silence. Voyager's instruments were built in the 1970s. Each probe carries 8-track tape recorders, radioisotope thermoelectric generators, and memory banks smaller than a modern USB stick. Yet despite their primitive hardware, they've outlived dozens of space missions, and almost even themselves. In 2021, Voyager 1 began sending garbled signals. For months, its engineering telemetry appeared incomprehensible. Theories swirled, even fringe suggestions of alien interference. But the reality was more mundane, if equally astonishing. A malfunctioning onboard communication unit had started sending telemetry through the wrong channel. It took months of detective work, but a NASA Deep Space Network engineer decrypted the chaos, discovered the error, and corrected it from 24 billion kilometers away. That's like hitting a moving grain of sand with a laser pointer from Earth to Pluto. In late 2024, Voyager 1 experienced another serious malfunction. Scientists feared this time it was permanent. But against all odds, the probe came back to life again. A signal pierced the cosmic silence, and Voyager continued its journey. Voyager 2, too, has had its moments of silence. But both spacecraft are still transmitting, bit by precious bit, from the edge of the known. Milky Way, why the interstellar medium matters. The interstellar medium, ISM, the space between stars, is not a true vacuum. It is filled with faint gas, cosmic rays, dust, magnetic fields, and plasma. Before Voyager 1, we had never directly sampled this environment. All models were theoretical. All assumptions untested. Thanks to Voyager, we now know. The ISM has structure, not emptiness. It interacts with the Sun's heliosphere, shaping the protective bubble around our solar system. It may affect the trajectory of cosmic rays, the solar climate, and even how stars like the Sun evolve over time. In a galaxy where stars are born, live, and die over billions of years, the ISM is the womb, the battlefield, and the graveyard, the stage on which the cosmic drama unfolds. Crystal ball, the final frontier. What happens next? NASA engineers are racing against time. Voyager's power sources are fading. The radioisotope generators, powered by decaying plutonium, lose about 4 watts of power each year. By 2030, both probes may fall silent forever. But until that day comes, every byte of data they send back is invaluable. Scientists are using it to refine models of the galactic environment, understand cosmic radiation, map the magnetic fields between stars, and glimpse the invisible threads that connect stellar systems across light years. When Voyager's last signal is received, the probes will not vanish. They will continue silently sailing through the Milky Way, each carrying the golden record, a message to the stars from Earth. In 40,000 years, Voyager 1 will pass within 1.6 light years of another star. Whether anyone will be there to receive it is unknown. Globe showing Europe-Africa, a legacy of wonder. Voyager is more than just a scientific mission. It is a testament to the human spirit, our longing to reach out into the unknown, to learn, to explore, to dream. Its discoveries have changed textbooks, inspired generations of scientists, and helped us see our world and ourselves with new eyes. As Carl Sagan said when Voyager 1 looked back and photographed Earth from billions of kilometers away, look again at that dot. That's here. That's home. That's us. So as we listen to the faint whisper from Voyager 1 once more, we are reminded of what we are capable of. In a universe so vast and cold, this fragile machine built by human hands is still out there, bravely voyaging into the infinite night. Loudspeaker, subscribe to the universe. This story isn't over. As long as Voyager continues to transmit, we are still discovering the universe in real time. Backhand index pointing right, subscribe now to follow every new signal from the edge of forever. Because out there, in the darkness between stars, our oldest emissary still sails on.